Okay, so I had a quick walk. Little dog is laying down again, so we'll see. I think I've got about an hour until my wife comes home, so I'll probably leave because it's Friday and it's nice. Well, it's kind of gross outside, but I'm gonna try and make it outside before it starts raining. Off camera, unfortunately, I was able to work a little bit more, and I have. Oh, I should stop getting in the habit of this, but I've got my. Well, you know what? Let's move this to another screen so I can see it. Um, Choice of tiling window manager. So now I'm back here, so you can kind of see I've got this counter going. I ended up writing a little function, and I'll show you this in a second, to update a little thing that takes a U16 and puts it out on the display, and it's just counting up with every 10 milliseconds. So it's essentially the top two digits are sort of a second counter, but it's not super accurate, and it looks really flickery for you, but it looks really fast for me because I'm only at 30 frames a second, so you only get to see some of these. But yeah, so I have this. So obviously we know that the very basic write works. I'm gonna get my music going again, but what I'm going to do now is wrap this up in a little driver and maybe do some of the more advanced modes, because it doesn't just support writing characters, and I'm only using one of the write character modes. I should probably instrument some of the other stuff. So let's start refactoring this out to a driver. Okay, so let's move this into another module. So let's break that. Touch source. I don't know what I should call this. I should probably call this something. Thank you, Tim. Oh, I need to write a blog post. Okay. I'm gonna call this the Spark Sir 7seg. .rs. That's an awful name, which means it's going to stick around for forever. So let's start with the struct. I guess this is going to be namespace. So sevseg is probably a good enough name for now, and we're going to have. Oh, it's going to end up being sevseg spin is what this one's going to end up being, because it's a spy master, because there's going to end up being like 3 different ones. Yeah. But we're going to have our spin, which is going to be a... Let's go look at the embedded-hal. Let's jump straight to making this an embedded-hal. Let's go up to, can I go up a level? Let's look in embedded-hal and let's look up spy. I'm probably gonna be probably, do I want the blocking one? I probably want the blocking one. Where's my modules? Let's go look at spy blocking. Because for right now, I think we only have blocking versions of this anyway. So trait is going to be transfer. I don't know whether... I don't think we need to have any of the data that comes back. But yeah, let's try and use the write iter. So let's use embedded-hal blocking spy write. No, let's use transfer for now. transfer. I think most will use transfer. And then I'm going to use the embedded-hal digital output pin. It's going to be a transfer. I think transfer has a type associated with it, but CSN is going to be an output pin, and I think that's, I'll probably end up having some other state stuff in there, but yeah, that's going to work because I don't have this in a module. Oh, so I can show you the code that I wrote real quick. It's really bad. So I just have a number that takes my SPIM and my chip select, and then a number, U16, it makes sure that it'll fit on the display, and then it writes the most significant, it just divides by 1,000, then it moduluses by 1,000, divides by 100, modulus by 100, divided by 10, and just modulus by 10. There's probably a much more efficient way to do this, but this chip has a hardware floating point on it, so this is still only a handful of instructions, so it's good enough for now. But yeah, I'm sure I'm gonna write something that's this good now, and someone can come in and PR a more efficient version of this, because I'm sure there is some theoretically optimal way to do this kind of display formatting. I know Japark is working on a smaller formatting library right now, so maybe we'll use that, and then I don't know, we'll see. For now, this is going to be a thoroughly good enough, and then someone can come and PR a more efficient one if they have a more efficient one. But let's go ahead and do a mod spark. Oh, I immediately need to change this. So this is this, and let's rename this, because you can't use, this is probably what the name of the crate is going to be, but yeah, spark sir 7 seg. One type argument. Yeah, I think I need to make this transfer W. Transfer W, where W ends up being, I think you need to be U8. Maybe, because I think this is the word size. So I think this is going to use a U8 for the word size. Associated type error. Okay. Pub trait transfer type error. Can I not? What I'm going to do is I'm going to go cheat, and I'm going to go look at the code for the DW1000, because I know Hano has already made this generic, and I can never remember off the top of my head what I need this to be. So let's go look at the source for this. Low level spy. Oh, okay, so I should probably go look at the low level version of this, because that's the one that's going to actually wrap the low level source. Oh, cool. So let's just do what he did. Spim CS, and spim is going to be a spim, and you're going to be a CS. Yeah. Does he not have any constraints on this? I guess it's going to be where Okay. Impl spim cs segment spim pub for new is gonna take a spy spim. Let's be consistent. And a CS. CSN. Let's change this just so it's consistent. Expected. Can I just eat that? I can't remember when you need. Yeah, that's fine. Self takes into account the types. Okay, and then yeah, I'm gonna need something that's roughly this. So let's take this. Whew, I do not need all of this good stuff. Let's just take this. Where spim is a spy transfer and spy write, sure. Complaining spy, that's fine because cool. And then let's move over our function here, and we no longer need these. And this is going to be what? Self dot spim dot transfer, but the transfer method on embedded-hal is slightly different. Transfer. Oh, right. I have to do this outside of there. Self dot csn dot set low. Actually, I don't want to return let ret equals this, not with the question mark, and then self.csn, because I don't want to return without setting the chip select back high. So I need to save that off for a second. CSN, where is CSN? And transfer is not that, it is that. Or spim xed. Yeah, no, I don't need that anymore. Found U8. You're just mapping the... Sure. This is a dumb that I'm doing. So I take the spim and I transfer. I'm sure cargo format will disagree with me here, but cool. And I'm just casting away all of the possible data that it could return. That's cool. So cool. So what I'm going to end up doing now is making this spim and display. This is actually just going to be a static mutt display. Is going to be a and it's going to complain that this isn't pub type, probably all over the place. Pub. So now it's very public. Is going to be sev. What is it? Sev seg spim. Sev seg spim. Types. You're going to be probably a U. No, what is your type going to be? Your type's going to be yeah, I guess you are. I guess you're going to be a this, and then you're going to be a this. That's a lot of types. And let's get rid of you. And then instead of U2, display is going to be Spark sev new with what is it, spim and CS. Does not compile. Resource has not been declared. Well, fair. And then you're just going to be none of this. And you're just going to be resources dot display dot set num. You don't need that. You just need the counter. Nope. Sev seg spin. Okay, right. Let's just use that. Use Spark sev seg spin. Yep. And then down here, let's just get rid of that, and that is use crate. Nope. Why did I hit Control D or something? 1, 2, 4. What? I don't know why you are here. That was a weird paste. Function is never used. Well, fair. Let's get rid of some of these constants. And let's get rid of some of our allow unused imports. Yeah, that's fine. Unused imports. Yeah, it's fine. Okay, you know what? Let's just throw a hammer at it. And I'm not going to use the delay. That's fine. That's fine. Okay. So actually now I've got a... Hey look! Embedded-hal capable driver. Portable code. Yeah. For the one thing that it can do. But, hey, still a thing. Look at me. I'm using portable types. Okay. So this is a thing. So now let's go figure out what else we can do with this. Okay, so this is just like the raw writing back. Moving the cursor. We assume the cursor. So I should probably... so let's make a pub. So I'm gonna end up having a bunch of consts. There's probably some kind of enum that I could do here, but for right now, let's use const command set cursor let's do a mod command const set cursor, which is going to be a u8 equals ox79 according to this. Pub set cursor and let self, and then it's going to be a call, and then I'm guessing 2, 3, we assumed, was it digit 1 would overwrite the 1 at position 1. Oh good, it's 1 indexed. Oh no, then send between 0 and 3. Call is also going to be a u8, and result, yeah, I know, my result types are bad. Pub fun set cursor is going to be a let's see, I should probably end up having things that return like internal methods that determine the data that actually needs to be sent. So I'm not doing multiple transactions, but again, this is good enough. We'll optimize later. So if call is greater than or greater than or equal to 4, return error. Then what I'm going to do is I'm going to end up having a helper function for this. I have a feeling very quickly. It's going to transfer. I don't need this to be transfer. I need this to just be write, really. Let's just try write, and let's see if this panics, basically. Is gonna be command, this is gonna be what? Command set cursor, and then it's gonna be call. And it's going to complain because module scoping. Set cursor. Okay, that's fine. Oh, no, that is how that works. Great. Okay, so that works. So call is greater than equal 4. So actually at the top of this, we're going to need to... Yeah, I really don't need to do true transactions here, but whatever. Self dot set cursor 0. Just to make sure that we have the cursor. Cool. And let's, you know what, let's screw this up just to see if it does break. So this should like end up wrapping around, I think. Cargo run, so this is gonna end up looking like a weird, where the leftmost digit, so yep, you can see that it wraps around in kind of a weird way where the most significant digit's actually off to the side a little bit, which is lovely. So let's put that back. And let's have a non-public function called fun send, which requires an and mut self, and then a u8 slice. Yeah, it's going to be an and u8, and it's going to return result that, and let's just take this. Why do I have 2 here? That's wrong. Set low, write data, pi. So now I can replace all of this with self dot send data and ret, and then this is just going to be self dot send data Yep, let's refactor the code a little bit. Lovely. Now you're working. Not optimal because I am doing 2 different transactions, but whatever. Cool, so that's columns. I know there's going to be a clear display. Here is hex 76, so pub const clear display is going to be it. Ooh, excuse me. $76. Cool. So pub fun clear display, or let's just call it clear, and mut self, and it's just gonna be self dot resets cursor. Self dot send command clear display. Cool, so that works. I maybe should clear, but I guess the num is gonna write the whole display, so it doesn't really matter. I guess I should have a do they have, and actually not all characters are displayable. There's a big old table here that has letters and stuff. They have some trickery here which gives you ASCII A through F. Do they have all lowercase and uppercase? This hurts my eyes to look at. Okay. I should probably support letters and stuff. Let's just support hex for now. Let's see. Set num is probably fine. What else do I need? I need all right, let's implement the hex and then we'll go from there. Let's do a pub fun write digit and mut self result and then if digit is just going to be a U8, if digit is greater than XOF, return error, otherwise self dot send digit. And then let's throw in a let's make right digits, which takes a U8 if digits dot len is greater than 4, that's going to be an error. Or for d in digits, if d is greater than x OF, return error. This is too many digits. Any digit too big. Otherwise, it will just send the numbers as they are. Send digits. But I don't want digits because, well, I guess, yeah, I guess this is fine. The question is whether I want to fill it out with zeros to write exactly this, but I don't particularly care. I'll let the user do it. This is where documentation is nice. I'll do characters and stuff later. What are some other, let's go look at the docs and see if there's any other useful stuff, because otherwise I'm going to clean this up and call it good for right now. There's like a special commands, reset, decimals and stuff. Okay, I should probably just transcribe all of these to start with. So pub const decimal control. It's going to be a U8 OX77. Set cursor 1 bit per decimal. Clear display. Let's be consistent. Nope. Let's match case. Cursor control or cuddle 79 pub const brightness control U8 pub const digit 1 control. It's going to be a U8. Hey, if you're in chat and if you know, I know like I can do a repr U8 enum, but if there's a nicer way to do what I'm doing with these consts, let me know. Otherwise, I'm sure right after this stream, someone's going to complain, but const digit 2. Ooh, are you chewing on the couch? Don't be chewing on the couch. This is the boring part. I probably should just be copying and pasting this because there's really no value in typing this out. e pub const come on, buddy. That's not what I want. Let's go find one of your toys. Let's find you something more constructive to chew on. Hey, how did you chew on this? Let's stay away from the couch. Pub const baud rate fig u8 equals ox7f pub const I2C adder what 80 and factory reset pub const factory reset. I'm not going to end up using all of these right now, so I'm probably going to also say allow unused, but ox81 expected for if it's fine. And within this module, allow what is the actual lint here? Allow dead code, just within this module. What up, buddy? The dog is giving me eyes like he is very bored, which is understandable because he was taking a nap, but now he's awake from the nap. Let's see. Clear the display. This is really decimal colon. This I should use the together so the two decimal points can never be individually controlled. That's cool. So this is going to end up being, this is one of those. Okay. Let's go look at my crate because I'm going to end up pulling this in. It's bit flags is what I want. I'm going to need to pull this out into its own crate here shortly. That may not happen today, but I will push this. So if you end up wanting or needing this, and then you can. So let's go look at where do I define my bit flags thing? Is that in lib? Nope, that's in Vecca. Bit flags. Let's see. Use bit flags, and then I'm gonna make a bit flags module pub struct. These are no longer day flags, these are punctuation is gonna be a U8. Okay, so we're gonna have this is going to be digit. This is between 1 and 2. This is going to be, what is this? It's going to be dot between one and 2. This is going to be dot between 2 and 3. This is going to be dot between 3 and 4. This is going to be dot right of 4. I'm sure someone is going to be annoyed by these very descriptive names, but you can come up with your own aliases. This is going to be both colon dots colon. Is this actually even right? So digit, yeah, 0, 1, 2, yeah, that's fine. Dots colon, and then 5 is going to be pos dot apostrophe between 3 and 4. That's an obnoxious name, and I apologize for whoever who has to actually use that. Okay, and that's the highest, and the top 2 bits are not used. And we can come up with combinations later, but I don't think I need those right now. What did I do there? Days of weeks. What was it when it was days of weeks? Day flags. Okay. Punctuation flags. Okay. So let's do a 2-byte sequence 77. Cursor control, brightness control, digit 1 control. Wait, how do I? 77 decimal control. Okay, I'm gonna change. Well, this is punctuation. Pub fun right punctuation and mutt self punct flags is going to be punctuation flags. And there's some kind of sanity checking that I think I can do. Can't remember how to get it just as a U8, but let's docs.rs/bit flags. Drop any bits. I don't know. Well, I'll let them not screw it up. Self.send. Send command decimal control And then punched flags dot, where's the return the underlying bits? Decimal control, not found in command. Okay, so we should be good now. So let's go over here and let me make sure that these all turn on in the right way that they're supposed to, but you know what I'm gonna do? I'm gonna do something really ugly just to make sure that it works. Let's see, there's what, 6 bits? 1. Let's see, I think if I do this, ugh. What are you doing, buddy? Oh, yeah. I think it's about time to play with the dog. Okay, well, we're getting pretty close. I've got a mostly working driver. Is there anything else interesting? I'm going to assume that works. I'll come back and test that later. That's a good way to approach this. Brightness control, that'd probably be good. Brightness is important. Brightness command will have no effect on the currently displayed values. The display will remain the same. Brightness control command 0. Huh. Individual segment control. Yeah, I'll do the fancy segment control later. This is the one that I'll probably actually end up doing the 7-segment display. So I might end up taking the existing 7-segment display crates here and doing some kind of representation. But yeah. Baud rate has some stuff. I squared C, yeah, there's some factory reset stuff. Yeah, there's a couple things. I think I could fill this out probably in about one more session, but I have a working driver. It's embedded-hal friendly. Yeah. How long have I been going this time? I'm going for about an hour. My dog's getting rowdy and my wife's heading home, so I think that is my clue to wrap up. So thank you everyone who watched, but I will finish this up probably the next time we have, and then I'm going to end up making, if I have time to go to the store, I'm going to end up buying some foam core board and making like a little mock-up of what my alarm clock is going to look like, just out of foam core board. I picked that up from Adam Savage's One Day Builds. I'll probably do that. If I don't, I have a bunch of cardboard here because I've ordered stuff on Amazon, so I'll end up making like a cardboard mock-up of what my alarm clock should look like. I'll kind of mount this board in there with this display. I won't put a battery in there yet. Maybe I will put a battery in there yet. But I also haven't done any low power stuff, so the battery probably will not last particularly long, especially with this max brightness. But I'll have a little USB cable sticking out of there, and then I'll be motivated to go do my network time protocol where I'll periodically send stuff out. But yeah. Cool. Well, I think that's all I need, and then next time maybe I'll have a little hardware box that I'll have. So maybe you'll see a somewhat nicer looking cardboard box, and then once I have everything that I want working like that, I have some wooden boxes that I'm going to use, and I'm going to go get a Dremel and drill those out. But we'll use the cardboard box version for a little bit, just for prototyping. So thank you very much for watching. I'll push this work up in the branch. Let me go ahead and commit and push. Git add I. Let's see, I need 3 through, I don't know why this has a lock file. It shouldn't have a lock file, it's part of the total crate. 3 through 7, well, let's add the lock file. It's an application. Working with a partially split out embedded-hal driver. Git push origin POC Sparkfun 7 seg. So this is push. So if you're watching this, you can at least go look at my code before I have time to finish this up and polish it. I'll even open up a PR. Serial 7 segment driver for embedded-hal. Cool. So that's even a PR. So you can look at what I've done. Oh, it's still got. Well, I might need to rebase this. Did I not push to master? Git push origin master. Oops. So now if I refresh, this should look much more. Well, this will update eventually. Okay, I gotta go. Thanks for watching. Yeah, catch you all maybe later today, but probably tomorrow. Okay, bye.